So let R be a square region and n greater than or equal to 4, an integer. A point X in the interior of R is called, oh my, let's zoom in, is called n ray partitional if there are n rays emanating from X that divide R into two triangles of equal area. How many points are 100 ray partitional but not 60 ray partitional? Okay, so let's draw the square R, and we're going to assume it's a unit cube. Okay, so firstly, the first thing you should notice is that X has to be connected to every single one of the vertices. This has to happen. Otherwise, you're going to form a quadrilateral. If there is no line like that, then you consider like these two lines, the leftmost line connecting to the bottom and the lowest line connecting to the left-hand side. And then this shape here is a quadrilateral and you're dead. So you have to have the lines from X to the vertices. So yeah, 1x is, the first thing to notice is that X has a line connecting to each vertex. And the second thing to notice is that the area of the greens is equal to the area of the reds. Why is this true? Well, it's a commonly used. This is a reoccurring idea. Basically, you have these two heights, height A and height B. And so the total area of the greens is going to be height A times the side length over 2. Height A times side length over 2. And this is going to be height B times the side length over 2. And the sum of this is going to be height A times sum over 2 plus height B times sum over 2, which equals height A times height B plus height B times C over 2 times S over 2, which equals S squared over 2. And so half of the area is in the green regions. So yeah, we have that the red regions and the green regions have the same area. So these are the first two observations you need to make. And then now the final thing. Oh yeah, so now we try to characterize 100 ray partitional points. So a point is 100 ray partitional if you can divide it into 100 triangles, all of which have equal area. And then because we know that the red and green have equal area, that means that red will be split into 50 triangles. Green will also be split into 50 triangles. And so when is this possible? This is possible when this specific region, like T1 over here, this triangle's area has to be of the form like X over 100. Yeah. The area, so the area of triangle 1 has to be equal to some number, some integer k over 100, for example, because we're splitting the entire thing into like, yeah, so since these lines are already drawn, this red triangle, triangle 1, will be split into a bunch of smaller triangles, and each of those smaller triangles will have an area 1 over 100. So that means that the area of triangle 1 has to be of the form k over 100. And this means that the distance from X to the side length, it has to be k over 50, because k over 50 times 1 over 2 will equal k over 100. And similarly over here, the height will also have to be m over 50 in order to satisfy this lower triangle. And so we've in fact fully characterized, and this is, you just split the lower triangles now, like this lower part, you'll just do them every m, you'll split into m triangles, and then this is possible. So we can now define a point is n partitional if it's of the form a over n, b over n. In order for a point to be n partitional, it has to be of the form a over n, b over n, where a and b are like between 0 and n, because it has to be on the interior of R. And so these are all of the points that are n partitional. And so now that we have the definition of n partitional, we go do the answer extraction. All right, let's try to answer extract now. So how many points are of the form a over 50, b over, oh yeah, it should be n over 2. How many points are of the form a over 50, b over 50, but not a over 30, b over 30? That's what this problem comes down to. And so really, okay, so firstly, these, you have to get rid of those 3's in the denominators, or you have no chance of it being equal to a over 50. And so this will, basically the intersection of these two sets of points is going to be the set of points of the form a over 10, b over 10, because like the greatest common divisor of 30 and 50 is 10. And then so now you just count the number of pairs a comma b that aren't of the form, that are of the form a over 50, b over 50, but not a over 10, b over 10. So the answer is 49 squared. There's 49 ways to choose A and 49 ways to choose B, 1 through 49, minus 9 squared, because this is the number of ways for both A and B to be multiples of 5, because 5, 10, 15, 20, 25, 30, 45, 35, 40, 45. And this gives you a total of 2,320. I don't know how visible that is. And this is answer choice C. And that's the solution.